coming at you from West Virginia. Hey everybody. So I think it's time for Joke of the Day because it is the best part of the day. So if towels could tell jokes, well, they'd probably have a dry sense of humor. So thank you JD, my son, for that background music, Stairway to Math. And now let's stairway ourselves to combinations. So combinations, we've already talked about permutations, and permutations is where we are selecting objects, but the order that we arrange those objects matters tremendously. Order matters. But here with combinations, we are still selecting objects, but the order does not matter. In other words, we've got a big group of stuff, and we're selecting maybe not even all of it, maybe we're only selecting some of it, but when we select that part of it, the order in which we place them makes no difference at all. We just want a big old group. We don't care how they're arranged. When that happens, we are dealing with a combination as opposed to a permutation. Now the symbol for combination, you may see it looks very similar to the symbol for permutation, because the symbol for permutation said P in objects chosen are at a time. And let me add that back up here again. This is going to be in objects selected are at a time. And so like I said, permutation, combination, very similar in that permutation had a similar symbol to it, except it had a P instead of a C. So C will denote combination. But we have the other arrangement for permutation saying in objects selected are at a time. Here's where the difference lies. With your formula for permutation, remember it said n factorial in that numerator, and in that denominator it said let's take these two and subtract them, n minus r, and do a factorial of that in the denominator, so that we could see what's left over. In other words, these are going to cancel out some of those, and we're going to see what's left over. Combination, you can see, looks a lot like this. The only difference is now we've added this r factorial to that denominator. So whenever you are selecting objects and the order in which you select them, once you select them, or we don't need to arrange them in a particular order, then that means we're going to do a combination and we're going to do this formula. So let's take a look at this example. It says, and I'm going to kick back to the example we looked at before when we were doing permutations. It says there are 12 students trying out for that trumpet section of All County Band. But we're still only selecting 8 of them. We had done this before with permutations, but we said, okay, once we select them, we place them in their particular chairs, and the order in which we arrange them matters. This time it says, you know what, the trumpet section is just a big group. And the order that we arrange them, actually there is no arrangement. Order doesn't matter. It's just one big happy family in that trumpet section. So if that's the case, we want to say, how many ways can we select those 8 students from the group of 12? So since order doesn't matter, that means we have a combination. So what that indicates is I have a combination of 12 students, 8 of them selected at a time. And again, I'm going to show you the different way to write that. That simply says 12 objects combined, selected 8 at a time. So the formula says, again, very similar to the permutation formula. I'm going to take this first number and do a factorial of it in that numerator. I'm going to subtract the 2 in the denominator, and then I'm going to do a factorial of that difference, but I'm going to add to it, because it's a combination, this r here, factorial. The number of objects selected is going to get a factorial. Now, we know that order of operations says do what's inside that parentheses first. I need to know what that factorial is. So 12 minus 8 is 4, so I have 8 factorial over 4 factorial. Now with these factorials, you know that that 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On that denominator, the 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I like to put the bigger number here at the end so it knocks a whole bunch of this stuff out and they cancel out more. Not more, but the cancellation is easier to see. 4 factorial is going to indicate 4 times 3 times 2 times 1. Now, like I said, the 8, the 7, the 6, the 5, the 4, the 3, the 2, the 1, they all cancel out. Now here, I can do some kind of fun cancellation in that 4 times 3 is 12. So this 4 and this 3, because they combine to be a 12, cancels out with that 12 right there. So all I'm left with is a 2 and a 1. Well, that 2 cancels out with that 10 because 2 goes into 10 5 times. So all I'm left with in that denominator is just a 1, which I don't have to show. And in that numerator, all I have left is 11 times 5 times 9. So 11 times 5 is 55, and then 55 times 9 is going to be 495. So there are 495 ways that I can select this group of 8 students from 12. So like we had said before, that the idea that order not mattering, that it's just one big happy family, restricts the number of ways that we can combine these and we can make these groups. And that's exactly what we saw here, because we saw this type of problem back in the permutation question. And when we were looking at permutations, this was a much bigger number. In fact, that number in permutations was 19,958,400 ways. Boy, that's a big difference between that and 495. Because here, the order doesn't matter. Just one big happy family. Now, let's take a look at one more example, and that will do it for us on combinations. There's not much to be said about combinations. So in this example, Annette has rented a house for next semester, and she needs some roommates. So she wants to select 4 roommates, but she's got 6 friends to choose from. She wants to know how many different ways can she select those 4 roommates from 6 people. So what we have to ask ourselves, and in all of these problems where we are doing these selections, we have to ask ourselves, does the order matter, or is it just one big group? If order matters, it's a permutation, and we saw the permutation kind of likens to fundamental counting principle. The two kind of go hand in hand. But if order does not matter, it's a combination. So in this case, order doesn't matter at all. So Annette is going to do a combination here. She's got 6 total objects, but she's going to select 4 of them. It does say 4 at a time, but really it just means that I've got 6 in my pile, I'm only taking 4 of them out. Now, we've said before that another way to write that is to say 6 choose 4, but the formula for combination says we do our 6 factorial over, we're going to subtract the 2, 6 minus 4 factorial, and we're going to add 2. This is my formula for permutation. If the order mattered, but it doesn't, so we're going to add the 4 factorial to that denominator. Order of operations says do that 6 minus 4 first. 6 minus 4 is 2, so we have 4 factorial, 2 factorial, and now we just work with those factorials. So 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1, and 2 factorial means 2 times 1. The beauty is 4, 3, 2, 1 all cancels out. And now, as I look at simply having a 6 and a 5 in the numerator and a 2 and a 1, 2 cancels with 6 because 2 goes into 6 3 times. So all I'm left with in that denominator is a 1, and in that numerator all I have is 3 times 5. And 3 times 5 is 15. So I have 15 ways that Annette can select her 4 roommates from 6 people. So this is how combinations work. And again, the difference between permutation and combination. Permutation, order matters. And since order matters, we are not going to restrict as much. Combination, order doesn't matter. And since order doesn't matter, we're going to have much bigger restrictions. And so our number of ways that we can make things happen is going to be much smaller. Here's the difference between the 2 formulas. So if it's a permutation and order doesn't matter, we've got this. Take that formula, add the 4, or not 4, but add the r factorial if you're dealing with a combination because you're going to restrict it more. And I hope that helps. Have a great day.